All right, welcome ladies and gentlemen. This is our final naming video. This is on naming molecular compounds. And for this, you're going to need your notes open to page 21 in your notes. And again, apologies for my voice. So in this one, it's all about how do you name a compound if you have covalent bonding? What if you have multiple nonmetals? Blessedly, the rules are so much simpler because we no longer have charges involved, so we don't have to worry about things like Roman numerals. We don't have to worry about things like the crisscross method. It's actually ridiculously simple. Prefixes. We use prefixes, and we use prefixes to say how many of each type of element we have, and that's about it. It's really easy. It's just prefixes. How many of each thing do you have? So if you have prefixes in a compound, in the name for a compound, you know you have molecular, and therefore you know you have covalent bonding. So what are our prefixes? Prefixes are right here. So if it's mono, meaning if you only have one of something, we use the prefix mono. If you have two of an atom, we use the prefix di. 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is nona, 8 is octa, excuse me, 9 is nona, 10 is deca. Yes, you do need to know these, but it's only up to 10. So that's all we need to know. So we use prefixes just to say how many that we have. So how does it work? Naming molecular compounds. Well, if I give you the formula, all you need to do is name the compounds in the order that they're listed. So if like hydrogen is first, you'd name that first. You use prefixes to say how many of each atom you have. So if you have 2 of the first atom, you would say, if it was the hydrogen, you'd say dihydrogen. But there is an exception here. You don't use the prefix mono for the first element if it's 1. You do use prefixes for the first element if it's more than 1. So if it's 3, you would say, trinitrogen or, pentachloride or chlorine or something like that if the first one has more than 1. But if the first one is 1, we don't use mono. So that is the one exception, and we do need to know that. And then we change the ending of the second element to end in "ide," right? So that's actually similar to ionic in that we do have that second one. It will always end in "ide." So for example, N2O. This is covalent, it's 2 nonmetals, so it's di-nitrogen, right? 2 nitrogens. So di nitrogen, naming them in order, and then the second one only has 1, so it's monoxide, and again I'm changing that ending. So I'm using prefixes to say how many of each one we have. We have 2 nitrogens, one oxygen, so it's dinitrogen monoxide, and that's it. That's it. It doesn't really get any more complicated than that. If we had NO2, now, I would say nitrogen, and here's an example where I don't use a prefix for the first one because there's only 1. So I wouldn't say mononitrogen, I would just say nitrogen, but then I would say dioxide. So I do use prefixes on everything except if the first one has 1, and I'm changing that ending of the second one to end in "ide." Now, if you can remember that carbon dioxide is CO2, that actually summarizes literally all of these rules. So first of all, carbon dioxide, carbon and oxygen, 2 nonmetals, we're dealing with covalent bonding, so we know we have molecular compound nomenclature rules. Now, di, it tells us that we use prefixes. We use prefixes if it's 2 nonmetals, right? Dioxide. It tells us that we change the name of the second element to end in "ide." It's not carbon dioxygen, it's carbon dioxide. And it includes the exception. It's not monocarbon dioxide, it's just carbon dioxide. So it actually has literally all of these rules built in, and hopefully you know that carbon dioxide is CO2 because that's a very common compound. So just some examples. Name the following compounds. So CCl4, 1 carbon, 4 chlorines. Prefix for 1 is mono, prefix for 4 is tetra, but I'm not going to use mono on the first one because we don't use mono on the first one. So this would be carbon tetrachloride. Next one, Ni3, nitrogen, prefix for 3 is 3, prefix for 3 is tri, and I have iodine, but it's going to be iodide, so it's nitrogen triiodide. N2H4, prefix for 2 is di, prefix for 4 is tetra, so this would be dinitrogen tetrahydride. You wouldn't see tetrahydrogen, you'd say tetrahydride. CS2, carbon disulfide. And H2O, the technical name for water, is not water. It's actually dihydrogen monoxide, right? Sounds very, very dangerous, but it's just water. But that's its actual name, dihydrogen monoxide. Now, going in the other direction, writing formulas for molecular compounds. What if I gave you the name and I asked you to write the formula? Oh my God, it's so easy. Just look at the prefixes. How many of each atom are there? Because the prefixes tell you that, and make that be the subscript. And that's it. You're done. There's no reducing. Don't reduce down. That's really critical. It's just how many of each one. So for example, dinitrogen pentoxide. Well, what's nitrogen? That's N. What's oxygen? What's oxide? That's oxygen. That's O. How many nitrogens? Well, prefix is di, so it's 2. How many oxygens? Prefix is pent, so it's 5. So what's the formula? Right? N2O5. Boom, you're done, right? And dinitrogen pentoxide. There's no crisscross because there are no charges. There's no charges in this, so it's a lot simpler. It's just how many of each one do we have. So just for example, carbon tetrabromide, that's 1 carbon. Tetra means 4, and then bromide is Br, so it's CBr4. Iodine dioxide, di means 2, oxide means oxygen, iodide obviously is iodine, so that's I, so that would be iO2. Phosphorus pentachloride, well phosphorus is P, penta means 5, chloride is chlorine, so that's Cl. So that's PCl5. Dichlorine heptoxide, well di means 2, chlorine means Cl, hept means 7, and oxide, that's oxygen, so Cl2O7. Diphosphorus trioxide, so di means 2, phosphorus means P, tri means 3, oxide means O, so this is just P2O3. No reducing, no anything, just how many are there based on the subscript. And that's it. That's really pretty simple. So we're going to have a really quick worksheet for this in class that hopefully you can knock out pretty quickly, and then we're going to do a lab.